I wanted to talk through a couple of the Khan Academy practice exercises that you might see. One of the that's a video. Okay, so one of the questions was something like Professor Gonzalez teaches chem. There's 12 students. There's a 100-point midterm, and then it gives you a chart where you have to then tally the frequency of each option, right? So you could get an A, a B, a C, or an F. There was no D option. So I ended up saying, okay, well, if these are the frequencies, then what is the probability of each, right? So there were 12 total students. It turned out that there were 3 actually of each category, which is kind of exciting, right? So I ended up saying, okay, well, the probability of getting an A is 3 out of 12, which is a quarter. Probability of B, 3 out of 12, which is a quarter. Probability of C, 3 out of 12, which is a quarter. Probability of F, 3 out of 12, which is a quarter. Okay, so you make a graph. Instead of making the graph of the frequency, we're using almost the relative frequency. So that's something that you learned in Unit 1. So make sure that your scale shows that your probability of each event occurring actually is a quarter, so 0.25. This is a uniform distribution where all the probabilities are the same. So this one's kind of simple, and then I noticed that there were some other more complicated things that are occurring, so I wanted to just point some things out and then do another example after this. So there's a problem with Elena. She catches 2 fish. They're independent events. It says that in the problem. So we know that if they're independent events, the intersection is going to be equal to the multiplication of the 2 simple events. So and then I wrote the probabilities over here. So that's really what I did, like this salmon colored part right here, no pun intended. A 60% chance she'll catch a northern pike, 40% chance she'll catch a walleye. All this information is from the problem. I ended up writing it out here. NP is northern pike, W is walleye. So I put the probabilities here individually. And so I defined the random variable from the problem. So X is going to be equal to the number of northern pike caught in 2 fish snags. If you know that you're doing 2 fish, if you're catching 2 fish, you can either have, and then here's what I thought in my mind, right? So I said the number of northern pike caught in 2 fish snags. I said, well, then what can occur if you catch a northern pike for the first fish? Then you can catch a northern pike or a walleye for the second fish. If you catch a walleye for the first fish, you can catch a walleye or a northern pike for the second fish. So there's really 4 things that could happen. And Elena, she can either catch 1 of each, 2 northern pike or 2 walleye, right? So you want to be careful about the things that can possibly happen. So X is going to be equal to 0 if no northern pike is caught. So we're going to put this on the horizontal axis. 1 if one northern pike is caught. 2 if 2 northern pikes are caught. And so we have to figure out the probabilities for the vertical axis, which starts to get complicated because you can't just jump to the graph yet because we need to know what the actual probabilities are. So here, what are the probabilities for the vertical axis? We're going to use the tree diagram to find the intersections. So what I did was this first event, that the 2 possible things that could happen is that you catch a fish. It could either be a northern pike or a walleye. There's a 60% chance there's a northern pike, a 40% chance that there's a walleye. After you catch the northern pike, there's a 60% chance of getting another northern pike. And there's a 40% chance of getting a walleye. Same thing, if you catch a walleye first, there is a 60% chance of getting a northern pike, and then a 40% chance of getting a walleye after that. And then you can find the intersections by multiplying across the branch. So then you think, okay, well, what's the probability of getting 2 northern pikes, a northern pike and a northern pike? That's going to be 0.6 times 0.6. So if the random variable equals 2, that's going to be the probability of 2 northern pike. It's going to be 36%. The probability of getting a northern pike and then getting a walleye is multiplying together. It's 0.24. The probability of getting a walleye then a northern pike is 0.24 as well. So there's 2 ways to get 1 northern pike. You can either catch the northern pike first or catch it second. So I had to put these 2 probabilities together. So this is 0.48. Should say 0.48. It's cut off. It's supposed to be 0.48. No problem. And then over here, you can catch 2 walleyes, which means you're catching 0 northern pike. So when x is 0, 0.4 times 0.4 is 0.16. And so you'll see that I did these things on the graph. So I thought, okay, well, my largest number is 0.48. So, and looks like I'm, going up. Everything sort of seems nice with 12s, right? So 36, 48, even 16 is not too hard to deal with on a scale of 12. So I did 0.12, 0.24, 0.36, 0.48, 0.6. I just did that to make it easier for myself. And then when you look back, you're thinking, okay, well, x is 0. I got the intersection to be 0.16. So that's why I graphed the green bar as I did. The probability of 1 northern pike, there's 2 ways to do that. So it's a union problem. So we say you can either catch a northern pike then a walleye for 0.24%, or added to a walleye then a northern pike, and then that's why you get 0.48. So that's why this bar here in the middle is 0.48. So the probability of catching 1 northern pike in 2 catches is 0.48, and then the probability of catching 2 northern pike is northern pike and northern pike, 0.36. So that's where we're getting that height of that bar from.